All right, number 7, I'm going to go ahead and make this one full screen. This time we want to graph these exponential functions and then match the equation with the correct graph. Now, if you look at all these, they all have a base of 7. They all have a base of 7. But some things are different with the minus, the transformation of these, shifting left and right and up and down. So let's talk about what this looks like. Let's go back, recall transformations. I think y equals a parentheses. I think we use a bx minus h close parentheses plus k. So this was like the general form of the transformation. This guy at the back separated would go up or down. All right, this guy right here would go left or right, but it would do the opposite of what we saw. So if we saw negative, that means right, positive means left. This would stretch, V stretch, I'm going to just say VS, vertical stretch or compression, and this would be a horizontal stretch or compression. And this also did opposite. I'm going to say HS. Now, if this was negative, this term was negative, it would flip y-axis, flip, and I'll just say y. And if this term out front was negative, this would flip, flip across the x-axis. Okay, so you might have flips. So these were the general transformations that we talked about. The same will apply to these graphs. Okay, if the term out front is negative, it's going to flip it across the x-axis. All right, and so forth and so on. So let's look at this. This is y equal 7 to the power x. Traditional exponential growth equation. It's going to be going up. This one looks pretty close, except it should go through the order pair 0, 1. And I don't think this one does. This one goes through 0. It's really flat. So let me also show you this exponential graph in our parent functions, not grade center. I want to go to videos folder. I want you to kind of be aware of this in, I think it was in chapter 2. Parent functions, yes. Okay, so exponential right here. It goes through, and we can't see that great. And you can also see this in the text when we talk about the properties. But it goes through the point 1, 0 always, just the standard. And when we're looking at this one, it's really flat and going across at 0. So it looked like it maybe got moved down. So the one that its exponential growth goes through the order pair 1, 0 is 41. And there's no other that does exponential growth and goes through 1 that I can see. So this one is going to match with 41. Now let's look at some other stuff that we can kind of figure out pretty easy. Let's try this one. This one is growth but minus 1, so it got shifted down 1. So that kind of matches here. So if the original one goes through 1, 0 and it got moved down 1, it's still flat hugging this x-axis, but it just is no longer going through the order pair 1, 0. So this one looks like it matches 38. Okay. Now, what is the difference in this? Okay, this one is going the opposite way. Okay, so it looks like it flipped across the y-axis as compared to the original, because the original is exponential growth, and this one is just going the other way, so decay. So what flips it across the y-axis? Making the x value negative. So that's a negative in front of the x. So this guy right here looks to match with flipping across the x-axis. And if you ever have any doubt, you can always graph these. So I just want to graph and just show these two just to make sure they look like that. I'm going to graph them on the same graph. The window, I'm going to make it the same. So I'm going to turn this on. I'm going to go to y equal. I'm going to clear these guys out. In the top, I'm going to do y equals, it's already y equals. I'm going to do 7 raised negative, remember negative below 3, not the minus x. And then I'm going to arrow down, and I'm going to do 7 raised x, and then minus 1. All right, when I go to window, I want it to go from -3 to +3 like they have. So I'm going to put a -3 here and then a +3 just so you get a better image. And they go from, they show -2 up to 10. So my y minimum, I'm going to say -2, and I'm going to leave that as 10. I'm going to hit graph. So the first one we should see is going down like that, crossing at 1. And the next one is below the line and it comes up at 0. It doesn't look like that exactly, but I think that might be our best bet. Actually, it could be this one. Why is that one just flatter? Okay, yeah, so actually this is a good thing I'm throwing off. We got shifted down 1, so it's going to go through 0, not 1. So that one should match up there. So may be good to check and graph them, but that's the idea we get there. Okay, so with the rest of them, we'll continue with transformations that we've talked about. This -1 in parentheses with x, or in that exponential position with x, -1 should shift our graph to the right one. So that's this one. Remember, it would cross here. And instead of crossing at 1, 0, it's crossing at 1, 1. So this is the one that actually matches the one that I had previously selected as being shifted down 1, because it just got moved over. So that 1, 0 point from here got moved over. And now we have, let's talk about the negative out front. So this negative is thinking of flipping across the x-axis. So our graph traditionally would go up, and when I make the y values negative, this whole graph flips down and flips across the x-axis. So it'll be going down like that. Something like this guy right here. This would be the same as making that negative. So that was this guy flipping across the y-axis or the x-axis. All right, so we have 3 more to match up. This one, because of the negative x, it's going to make it look like decay, that it's going down. Let me see. Down like this, decay. And then this 1 being positive will shift it left 1. So it's kind of like taking this graph, making it decay, and then just shifting it over at left 1. But that doesn't even look really good. Whenever they do them like this, they get a little bit confusing. Let me see if I can write it out and get a better idea of what's happening with this graph. So, yeah, actually, that's what it is. So this is what's going on. I can do them a little bit better by hand. We have 7 raised to the 1 minus x. So if we kind of distribute this, this is what we're looking at. By properties of exponents, this is like 7 times 7 to the negative x, because you just add exponents. So we have these two guys being multiplied. This negative x, if you think about negative exponent, will move this down. So this will have 7, and then we'll have a 1 over 7 raised to the x. So it's kind of like we have we have this factor out front. This gets changed here. So this is what we have. What's going on? We have exponential decay from here, but we're multiplying it times 7, times a factor of 7. Kind of looks like a transformation. So based on that, if I were to pick a graph, I would not, out of the options that we have left, we have one that's doing decay, and then the other two are doing, they have been flipped, and our negative x flips it across the y, not the x, so it makes it look like decay. So this would be, I would match 44 with that one. Let's also verify it by graphing. Let's go y equal, let's clear out this one, and this one is pretty close to what we have. So let's just change this to in parentheses, I have to do it with the calculator. Let's do, where's that function at? We're going to do 1 minus x. So we're going to do 1 minus x and then close it. So what I'm looking for is an image that looks close to this. So when I hit graph, okay, that's the image we get. That's the only one that actually has decay. So that's what I would have chosen anyway, but I want to kind of get a better feel from graphing it. Okay, so now we have two options left. One of them flips across the x and the y, okay, and then one of them just flips across the x-axis, okay. So this, imagine we have exponential growth is going up. If I flip it, so let me write it out. It's hard to visualize that. So let me move this calculator out of the way. Okay, so that first one has a negative in the x and a negative in front of the y. All right, so this is what we're dealing with. This is our regular graph, like this. If I flip this across the x-axis, that's what this negative out front does. We would have this image. I'm going to do dot, 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 like that. That flips it across the x-axis. Then we flip it across the y by making the x's opposite sign. So what that would do is just give me this final image like this. So it flips in both directions. So I'm looking for a graph for that one to match being flipped and then flipped again. So kind of like it got rotated, 180-degree rotation. So the graph that matches that image, which is going down from that side, looks like 39. And by default, we would get this one just flips it across. We also got the shift that would go up 1 because that positive 1. So that one would match this one. So these work pretty much the same as transformations, but they're a little bit more of a challenge with the exponent and that negative there. But if you remember those, I'm going to kind of go over them a little bit. You can kind of come up with these, as well as you have the option to graph them and verify as well.